Hello and welcome to the first ever Wix Engineering Facebook Live. I'm happy to be here and talk about a topic that's near and dear to the hearts of most every web developer, performance. At Wix we care deeply about performance and invest heavily in improving it. In this session, I will share with you the techniques and methods that we've used to improve the performance of over 100 million websites built and hosted on the Wix platform. First, I would like to introduce myself. My name is Dan Shappir, and I'm the Performance Tech Lead at Wix. This means that I'm responsible for the technical aspects of the performance of all the websites hosted on the Wix platform, as well as Wix's own services and products. So at the bottom of this slide, you can see my email, you can see my Twitter account. Do feel free to contact me via either. I would love to receive your questions about performance, your comments about this talk and about performance in general, either through these channels or in the context of this Facebook Live. First, let me begin with our agenda for today. So to begin with, I'll speak about our motivation. What has prompted us to invest so much effort and resources into improving our performance? Also, I will talk about what does performance actually mean. What is it that we mean when we talk about performance, and what do we actually need to do when we want to improve performance? I will look at specifically at performance at Wix, speaking about what makes our own particular use case so special and interesting. And most importantly, I'll give you the practical steps that we've used to improve performance, specifically the load time of our sites and services, that you can also apply at your own websites or web applications. And finally, at the end of this session, we will have a short Q&A. You're welcome to send your questions either now while I speak or at the end of the session. I will do my best to answer any question that you might have about web performance. So, at Wix, we're constantly very, very busy. We have hundreds of developers, including front-end web developers, constantly working on adding new features and capabilities into our products and offerings. This means that we constantly strive to add value to what our users receive when they work on our platform. But it turns out that while we're so busy adding value, we're also taking some value away. And the reason is that in order to add new features and capabilities, we have to add additional code. This is code that then needs to be downloaded, parsed, and executed by the browser. And all these things actually take time. And the consequence of all this is that, for example, last year, between January and August, while we were adding so many features to the product, we were also making it slower. In fact, as much as 15 to 20% slower. What you see here in the different colors are the different percentiles. The change is not so evident when you look at the median loading time, but is very evident when you look at the 90th percentile. And when you think about the number of users that visit Wix sites and use Wix services, even the 90th percentile represents a lot of users. And so, when we saw this trend that was going on, we realized that something had to be done, and then we started working and investing heavily in improving our performance without taking away features and functionality, and also without slowing down the rate at which we advance the product. And fortunately, we've been successful. In fact, as you can see from this graph, starting from August, we've been able to improve performance of the Wix platform by 20 or as much even as 25%. But that definitely wasn't enough for us. We realized that if we really wanted to be competitive, if we really wanted to offer our users an excellent experience, then we had to take a dramatic step. And the dramatic step that we took, and which I'll elaborate on for a lot more during this talk, is by introducing server-side rendering. First, we introduced server-side rendering for mobile devices. We introduced that around between July and August of last year. What you can see in this graph is the impact of introducing server-side rendering, SSR for short, had on the performance of the loading time of Wix sites on mobile devices in the US. As you can see from this graph, performance improved by somewhere between 60 to 80%. That's a very dramatic improvement. But obviously, we didn't stop there. A bit later, we also introduced server-side rendering for desktop clients. And the gains there were not as dramatic as on mobile, and again, later on I'll explain why that is, were still fairly significant. You can see an improved performance of over 50% and usually over 60% in terms of performance. So all of this, as I mentioned, we've been able to achieve without taking away any of the product's functionality. In fact, while this has been going on, we've added even more significant functionality into the product, Wix Code, just to name one particular example. So the first item that I would really like to cover is to understand performance. What is it exactly that we mean when we talk about performance in web applications? And in general, in fact. So the first thing to understand is that you need to think about performance as a feature. What I mean by that is that customers expect high performance. So to them, being able, for example, to build a site and then having that site load quickly, or to build an online store and having that store load quickly so that customers can quickly see their products and make a purchase, is definitely a feature that they would like to have in their website. Likewise, Google rankings are now impacted by performance as well. So if your site has good performance, it means that it's more likely to be discovered high up on the Google search results. All these are examples of why performance is such a good feature to have. At the same time, it also means that good performance needs to be specified as part of the product requirements. If you don't specify performance, if you don't allocate resources and effort to making sure that performance is good and to improving performance where it needs to be improved, then it just won't happen by itself. It's not as if the developers will automatically make any website load as quickly as possible. You need to specify guidelines, you need to have a performance budget if you want that to happen. On the other hand, you should also think about performance as something which is not a feature. Because unlike most features, performance is never actually complete. It's not as if you have a requirements document to build a new feature, you work on that feature, you complete that feature, and then you can move on to the next feature. Performance is never actually complete, it's never actually done. And moreover, with performance, if it's not progressing, it's regressing. It's been our experience that whenever we took our foot off the pedal, whenever we stopped investing significantly in performance, performance almost immediately started to regress. So in this context, you should think about performance not so much as a feature, but more as a project or a product. It's a journey that you go through, you go down. It's not a destination that you ever actually just arrive at and you're done with it. Also, I would like to speak about performance at Wix. In order to understand why performance is so critical for us, you need to learn a little bit about who we are and what it is that we do. So Wix is the leading do-it-yourself web building platform. And in addition to that, we're also a cloud-based development platform. This means that you can build a website on Wix and basically have a total freedom almost in terms of what you build in that site, putting in features like e-commerce, like the ability to make bookings, etc. But it's also a platform for building web applications. So with features like Wix Code, you can now actually automate and add whatever functionality almost you would like into whatever website you build. In terms of growth and size, we have 120 million registered users on the Wix platform, coming from 190 countries. That means a very wide range of networks that we need to support, of devices, of browsers, and whatnot. And in addition to that, we get something like a 1.5 million new users every month. So it's a very dynamic and ever-changing environment. But it's all these changes are not just coming in from the outside, they're also coming in from the inside. They're also internal changes. At Wix, we have over 2,000 employees, and about 50% of those are in R&D. And in addition to that, essentially every one of these developers has the keys to production. Our approach is that whenever a developer makes a change and goes through the proper processes of continuous integration and continuous deployment, they can then push this change into production. The result is that we have a state change in our production environment roughly every 2 minutes. That is 200 changes a day, sometimes even more. And we have over 1,000 running experiments, including A/B tests and feature toggles. Just think about all the possible permutations that we have in our code. Now, obviously, we cannot check all these permutations and check the performance impact of every combination, which means that we definitely have to continuously monitor what goes on in our systems. So when you put all of these together, you'll see that Wix represents a very interesting, you could call it edge case, of where you want to be in terms of performance, and anything that can work for us can generally work for any other type of website or web application. Now, one of the most important tools that we have in our arsenal is that we're very thorough about how we monitor our products. And in fact, before that though, a few more words about the Wix Challenges. So as I said, tens of millions of sites and domains, millions of domains, a wide variety of site types, as I said, including e-commerce, including booking, including photography sites, music download sites, and just simple straight-on websites. Also, 7 years of legacy sites. This means that to this day we support sites that have been built 6 or 7 years ago and have not been modified at all since they were created. Even more significantly, whenever we improve the performance of our platform, we expect performance to improve for these sites as well. And since all the sites are designed by the users, usually starting with templates that we offer them, but they can really take their sites in any direction almost that they want and have almost total control over whatever they end up as the design of their website, we want to provide a good performance regardless. So a user might have a lot of images or few images. They might have a gallery or a video background. The number of fonts that they use is up to them. The number of permutations is almost infinite. And we want to provide good performance to all of these different permutations. So as I mentioned, one of the key tools that we have in our arsenal is constantly monitoring performance. And in fact, we monitor performance at three main stages. First, and obviously, during development time. We expect every developer, as they're working on a feature, to test the performance of that feature, to verify that they're not adding significantly adverse impact in terms of performance of the product. At the end of the day, any developer can simply add an infinite loop or something like that into the product, or a timer which fires every millisecond, and basically slow down the entire product to a crawl. We expect them to use tools such as Chrome DevTools and monitor performance, and we also give them internal APIs that they can use to hook up into services such as the Web Performance APIs, which can enrich the experience that they get via the Chrome DevTools and the development tools of other browsers as well. And the other end of the spectrum, we use what is known as RUM, which is real user measurements. So we collect a lot of anonymous performance-related information from user sessions into our systems, and then use that to track important KPIs that we've defined across the product. so we can monitor time to first paint, time to first contentful paint, time to interactivity, and so forth. This makes it possible for us to see changes in environments that might be very different than the environment in which we use to develop and test our software. For example, as I said, because they're running in a different country or using some other device. Or maybe it's a different combination of experiments than the one that we tested for during development. And then in the middle, we use synthetic tests running as part of our development of our testing environment. It's basically automated tests that run continuously and monitor the performance in rigidly defined and controlled environments. This lets us identify performance degradations even when they're really, really small. So for example, even a 3% performance degradation can be caught in the testing environment before it gets pushed into production. This is also extremely important for us because given the rate of change, even very small performance degradations can accumulate over time, ending up in a significant performance slowdown very quickly. So, having talked about both performance in general and about performance specifically at Wix, I think it's time to look at some of the methods and techniques that we've specifically used to improve performance at Wix. And as I said, I think all of these techniques are applicable to essentially any website out there. So, first of all, at the organizational level, we've had to make some changes in order to create, let's call it, a culture of performance. So, performance was declared a top priority company-wide by everybody from the CEO, the VP of R&D on down. So everybody in the organization knows that they have to constantly think and consider the performance implications of everything that they do, and that they get measured on the performance of whatever it is that they're developing. It also means that there's direct engagement from senior management in this topic. So a member from senior management can definitely come to a team and tell them something like, look, your performance is not where it should be. This needs to be changed. You pushed a new change into production, but we're in fact going to roll it back, even if it's a significant new feature, because it simply degrades performance, and that's unacceptable. In addition, we've allocated significant resources to performance. So we conduct performance reviews on all our projects, and the team members need to come in prepared and be able to explain and justify the various decisions that they've made. We have dedicated performance teams in key projects. So in addition to everybody who's working on stuff in general, but also need to think about performance, we also have teams that work specifically on taking, let's say, existing products and making them work faster. And finally, even in the smaller projects, we have performance leaders. They may not be dedicated just to performance, but they definitely have performance on their mind, and they can assist the other members in the project, in the team, in working on improving the performance of whatever it is that they're building. And based on all the measurements that I've mentioned before, we consider performance to be a regression and a blocker bug. So if we identify that a version or a change degrades performance, we will either block it from being rolled out into production, or if we only caught that degradation in production, we will in fact roll it back. So as I mentioned in the beginning, one of the biggest changes that we've made and one of the most significant performance boosts that we've been able to achieve was thanks to a technology called server-side rendering, or SSR for short. Server-side rendering means that instead of rendering the UI on the client side, has become common with frameworks such as Angular or Ember and others, we actually moved rendering to the server side. So now you get the rendering on the server, and later on also on the client when, for example, you transition between pages in the sites. So the initial rendering happens on the server, and then consecutive renderings or updates take place on the client. This is done often using something known as isomorphic code, when you have essentially the same rendering code running on both the server side and the client, and this is definitely possible with all modern frameworks such as React and Vue and Angular. So why is server-side rendering such a good thing? So one important reason is that servers are often faster than clients. With servers, you can purchase effectively and allocate very powerful devices, lots of CPU and RAM, to perform the rendering. And this is especially true when you compare to mobile devices such as smartphones. Another significant benefit is that servers can be made pre-hot. What I mean by that is that when you do client-side rendering, you need to download all the JavaScript code into the client side. You need to parse that code, run the initialization for that code, and only then can you actually use it to render the site. And has been shown often, for example, in a great article by Adi Osmani from Google, JavaScript is often the most expensive resource that you may need to download. With server-side rendering, you can have all this code up and running already within the server when the request comes in, and then when you need to fulfill that request and generate the HTML, you can do that immediately without needing to perform all the steps that I've just mentioned. And another advantage that you have in server-side rendering is that very often the servers that actually perform the rendering are alongside the servers that contain the data that you want to render. So fetching data also becomes much faster than when you need to perform some sort of AJAX request and download this data to the client, especially if it's live and dynamic data which can't be easily cached. On the other hand, SSR is not panacea. It's not, there are no free lunches. First and foremost, SSR can be really difficult for implement. We actually needed to allocate a significant number of engineers to implement, to actually transform our code, which was originally written for client-side rendering, known as CSR, into SSR. For us, it took several man-years to achieve this transformation. So don't assume that just because you're using a library such as React or Vue that it'll be very easy to do. It's definitely easier than it would be if you were to write this code by hand, but it still can be a significant effort. Also, servers cost money. Prior to SSR, our servers were essentially used only for storage and for delivery, for the network. We hardly used any CPU. With server-side rendering, we are using a lot of CPU resources, and obviously we need to pay for them. In addition, because we are a global company, we actually need to have data centers all over the globe in order to provide good performance to our users regardless of what country they connect to our systems. And another interesting problem or issue with server-side rendering is that it can actually introduce some performance degradations. In particular, SSR reduces the time to visibility. So from the time in which the user, a visitor on the site, clicks the link to navigate to the site, and until that user sees something being rendered on the screen, especially some meaningful content, that time can be significantly reduced by SSR. But the time to interactivity, especially full interactivity, at best does not improve, and at worst can even degrade. The reason for that is that after you download the HTML with the content down to the client, and after the browser actually renders that content, it still needs to download, parse, run the JavaScript that adds that interactivity to the site. So SSR doesn't in fact do anything for interactivity, and because of the delay introduced by achieving the earlier visibility, interactivity might actually regress. And that actually can create a certain period of time in which the user can see the site but may not be able to fully interact with that site. So things like links or maybe even buttons might work, but more complex user interface components that are dependent on JavaScript, like menus, for example, these might not yet be functional, and users, instead of maybe reporting that as a performance degradation, might actually report something like that as a bug because they try to open a menu and the menu just doesn't open if they click the menu too quickly. In any event, for us, SSR, as we saw from the graphs, provided 35 to 75% performance improvement, again, in terms of time to visibility on the pages that users visit. Another really important thing that I've noticed that is neglected in a lot of web projects is caching, proper caching, you might say. Caching is basically the idea that if you have previously requested certain content and that content is still valid, then you can use what you've previously received or requested instead of downloading it again. This can happen on the endpoint, so the browser obviously implements caching, but it can also happen in intermediate layers. So for example, if you're using something like a CDN for your content or for your resources, if you have proper cache headers, then that content will actually get cached in those servers, benefiting even people who are visiting that site for the first time. So first and foremost, you need to make sure that whenever you have web content, you specify proper caching headers. Basically, to cache that content for as long as possible. So, for example, if it's JavaScript, if you have the version of that resource or a hash of that resource as part of your URL, you can in fact essentially cache it forever, or as close as possibly can, which is usually a couple of months in web terms. On the other hand, if it's a dynamic resource, for example, if it's an HTML containing your bank balance, well, obviously something like that cannot be cached. So you need to select the proper cache headers for your content, and again, emphasizing the point that any content that can be cached should be cached for as long as possible. If you use libraries from common CDN, public CDNs, for example, let's say you're using React or you're using Angular, then if you're actually using the latest version of React and you're taking it from a public CDN, then you're benefiting from the fact that the user has likely visited other sites that have also used this library. And consequently, that resource will already be in their cache. And when they visit your site, that resource will not need to be downloaded again. Another beneficial technology is eTag. eTag basically means that when the server provides a resource, it can attach a signature like a hash, and then even when the cache expires, when the client makes a request, it sends that hash along. And then the server can respond by saying, based on that hash, what you have is still fresh, it's still good enough, you don't need a new version. Now obviously this doesn't save you can't circumvent the round trip in this scenario, but at the very least you might get a very small response instead of having to download a very large resource. And last but not least, you should avoid cache busters. Too often I see people just adding cache busters as part of the development process just to make sure that they're getting the latest and greatest, and then somehow this stays in production. And obviously this is a very bad thing, because essentially it means that with a cache buster in the URL, you'll not get any caching regardless of whatever you put in the cache headers, because each and every time the URL will be different. When you think about the resources that you're downloading, as I mentioned before, one of the most significant resources that might be downloaded as part of the session is the JavaScript. And you know, it used to be that JavaScript was really, really small and simple. We could just write a bit of JavaScript in Notepad or whatever, and then just put an src tag in the HTML and be done with it. That's no longer the case. If we look at Wix, a product like the Wix editor actually contains millions of lines of JavaScript that are developed by hundreds of developers working simultaneously on various parts and components. It's a modular, it has a modular design, and all this needs to be packaged or bundled together in order to be effectively delivered down to the client. And you definitely want to properly bundle it, which means that, let's say, let's say that the Wix editor is comprised of 1,000 JavaScript files. It's probably a lot more, but still. You definitely don't want to have 1,000 individual downloads taking place. So you want to use a bundler like Webpack to take all these files and then merge them together into a single file. Now, there are several benefits in that. One of the main benefits, certainly in terms of performance, is that you get much better compression. Compression works by identifying repeated patterns, and then replacing them with just shorter representation. Obviously, when you have a large resource, you'll get more occurrences of those repeated patterns. On the other hand, if you have many small resources, you basically start from scratch for each and every one of them. So you can definitely get something like double or maybe even triple your compression ratio if you bundle a lot of files together instead of sending them down individually. Also, when you send down files individually, you get a lot more overhead in terms of the protocol. This is especially true if you're still using an older version of the HTTP protocol, specifically HTTP 1.1, and I'll touch on that in a later slide. But even if you're using HTTP 2, there's still overhead associated with every request and response. You need to send a request, that's overhead of the upstream. You need to send a header along with the data, that's overhead on the downstream. And another problem if you don't bundle is that if you have, let's say, resource A that's dependent on resource B, and if for some reason, because of the network or whatever, resource A finishes downloading before resource B, resource A can't actually do anything until resource B finishes downloading as well. On the other hand, if they had been bundled together, then obviously when they arrive, everything is there and you can just run. Now, there are other advantages to bundling, like not putting too much garbage in the global namespace, but those are not directly related to performance, so I'll not really elaborate on those. But it turns out that there are actually some benefits in unbundling, that is, taking a large bundle and breaking it apart. Some tools, to the extent that some tools even support this intrinsically, and stuff like that is known as code splitting. So why is it beneficial to actually, after everything I said about the benefits of bundling, why can it be actually an advantage to take a bundle, a large bundle, and break it apart into several smaller bundles? Well, one reason might be a better use of a CDN. For example, I mentioned before that CDNs can be really effective when you're using a common library like React. So maybe instead of bundling React into your download, you can actually have it as a separate download coming from a public CDN, and then again it's already down there, it's cached, and you've at least saved the time of downloading that part of the code. Another advantage is that you get fewer cache busts. If you put all your code inside of a single large bundle, then every time any part of the code changes, you need to download a new version of that bundle. So any change that's being made causes a cache bust. Now again, if you go back to my description of the Wix environment, that would literally mean a cache bust every day. So by breaking the code into smaller components, we can at the very least ensure that a change will force a download of one package, but not of all the packages. Another advantage is to avoid downloading unneeded code. That specifically is useful if I can identify, based on the scenario, parts of the code that are needed in a particular session and parts of the code that aren't needed in a different session. So for example, I mentioned that in Wix you can build a wide variety of websites. So for example, if a site does not use e-commerce, then there's no point in downloading all the code that's associated with e-commerce functionality. If a site does not have embedded video, then again, there's no point in downloading the code that's responsible for playing videos. So by breaking down apart code into pieces that are responsible for specific functionality, if you can identify that certain functionality is not required in a particular scenario, you can avoid downloading that extra cost. And finally, you can actually achieve greater parallelization. This goes to the fact that JavaScript works differently than HTML. With HTML, the browser is actually able to parse the HTML and even render that HTML while the HTML is still downloading. This doesn't work with JavaScript. With JavaScript, you actually need to download the entire file. Only then can you actually parse it, and then you can run it. So that means that if I have a really large file, until that entire large file finishes downloading, the browser is actually just waiting for it to arrive. If I actually broke down that file into smaller pieces, then as each individual piece arrived, the browser can actually parse and even run that piece while it's still downloading the other sections. So ultimately, if there are benefits to bundling and there are benefits to unbundling, the solution is to basically do both. Sometimes you can use your tools. Modern tools make it a lot easier than it used to be, with technologies such as I mentioned, code splitting and tree shaking. But you can also do this manually based on your own testing and your own profiling. For Wix, just by using this sort of smart bundling, we've been able to improve performance by 5 to 25% depending on the network that is used. I mentioned HTTP 2 before. Basically, if you're not using it, you should be. HTTP 2 is the latest version of that protocol. There is in fact work being done on even newer editions like Quick, but for now let's just mention HTTP 2. HTTP 2 is the latest official version of HTTP, replacing HTTP 1.1. It adds data compression to the HTTP headers. So if we're talking about the overhead of the protocol, that overhead is reduced. It also adds something like HTTP, which is called HTTP 2 server push, which means that when the client makes a request for a specific resource, the server can respond with multiple resources in addition to that resource. So for example, if you know that when a client requests resource A, this means that they'll pretty soon also need resource B, then instead of waiting for the client to make that request, you can push down resource B immediately, and then when the client actually needs resource B, it's already there waiting in the cache. And last but not least, HTTP 2 introduced something called pipelining and multiplexing. Previously, with HTTP 1.1, you could also only really have one request and one response at a time. So when the browser made a request to a resource, until that resource arrived, the client could not start downloading an additional resource on that TCP connection. In order to overcome this limitation, browsers often open multiple TCP connections. So you would have something like 6 TCP connections from the browser to any server or domain that it was connected to, which meant that the browser could actually download 6 resources in parallel, but that's it, no more than 6. With HTTP 2, you actually have something called pipelining, which means that you have effectively you could say almost unlimited number of virtual connections within every actual TCP connection, and you can download multiple resources simultaneously. without having to open those multiple TCP connections and without being limited to the number of TCP connections. Well, actually it happened in the reverse. I can actually give you the benefit that we got from moving to HTTP 2 because a couple of months ago we actually had a problem where for technical reasons HTTP 2 was disabled for a certain duration and we fell back to HTTP 1.1 instead. And when we looked at the graphs and compared them, the performance before this regression and then during the regression and then after the regression, we actually saw a 10 to 20% performance degradation during that time when we were using HTTP 1.1 instead of HTTP 2. Another benefit of HTTP 2 because of the pipelining and multiplexing is that you can achieve greater parallelization per my previous explanation about bundling and unbundling, and that means that instead of limiting yourself to, let's say, 6 or 10 resources, you can go as high as 50 and really get the benefit of using the local processor while you're still downloading content. Another change that we've recently made is that we've leveraged CSS Grid to go all out for layouting using CSS instead of doing it with JavaScript, or at the very least doing as little as possible with JavaScript. Unfortunately, we're not 100% there yet. Currently, this change is open only for mobile devices that are connecting to Wix, and even then for approximately 50% of the sessions. But it's definitely our goal to reach 100% within the near future. What we saw is that when we've done that, we've been able to achieve up to a 50% reduction on the time to visible, which, well, actually slightly less, 20 to 35, but I'm actually optimistic of being able to reach a higher number as we proceed. Another technology that I highly recommend looking into is something called resource hints. Basically, that means putting a link tag in your HTML or in the HTTP response header that informs the browser that it should perform a network operation. That might be to download a resource or to fetch a resource before it's actually needed, you might say. So what is the idea? Let's say you have a site and that site will need a certain resource once a user performs a certain interaction with the site. You can wait with this download until the user actually performs that operation. But then, when the user performs an operation, there will be a performance hit in terms of responsiveness. Instead of immediately responding to the user interaction, the user will need to wait for that resource to download. Preload makes it possible for the browser to download that resource even before it's officially needed, do that download as efficiently as possible in the background, and just keep it around so that when it's needed, it can immediately be used. There are different types of resource hints. There's prefetching, which is commonly used when you're downloading resources that be used in future pages, but not necessarily in this page. That's preload, which is used when it's resources that will be used in this page, but not immediately. And there are other options as well, like pre-connect and DNS prefetch. Really, this is a huge topic and probably deserves a lecture all on its own. For us, making effective use of resource hints has improved performance by about 10%. But I've also seen more significant improvements in other websites and other services. Progressive rendering, I won't go deeply into that. Basically, it means that instead of rendering everything all at once, you render just the content that's immediately visible to the user, often referred to as above the fold, and then continue to render content in the background while the user is viewing or interacting with that initially visible content. For us, implementing progressive rendering improved performance by 5 to 10%. But it can go up to as high as 50% on really heavy websites that have really heavy components below the fold, or just very, very long pages. And last but not least, obviously want to profile and optimize your code as much as you possibly can. That means identifying hot code, code that gets executed a lot, which constitutes the bottlenecks in your code, maybe replacing algorithms and data structures, using those old days when we used to implement the sorting algorithms ourselves instead of just using the sort method. That would mean, let's say, replacing bubble sort with quick sort. And preventing something called de-optimizations, which again is a big topic and goes beyond the scope of this lecture, but basically means that we are getting in the way of the JavaScript's engine own built-in optimizations mechanism. Just by properly and thoroughly profiling our code and making sure that we're writing efficient code and concentrating on those parts that really make an impact when you improve them, we've been able to achieve 10 to 20% performance improvement. To summarize everything that I've talked about so far, you have to remember that your customers, whatever service it is that you're providing, whatever your website is about, your visitors, your customers have alternatives. The web is huge, nobody is unique, and that means that you've got to provide good performance to your visitors. You've got to demand that from your product managers, from your developers, from your quality assurance team. They've all got to be dedicated to providing good performance. You need to make sure that performance is part of the product specification. You need to constantly measure performance, as I mentioned, during development, during testing, and in production. And you have to allocate resource to improving performance. Good performance will not automatically happen on its own. I'd like to thank you all for joining me, but remember, this is not over yet. We still have a Q&A part to this, so if you're willing to stay on for a bit longer, so am I. So let's go ahead and start answering some of the questions that hopefully came in. Okay, so the first question is about what Wix does to compress images uploaded by users. Basically, one of the biggest resources that can have a significant impact of performance on a site are images. If you put a lot of large images on a website, these can take a long time to download and can obviously have a significant impact on the performance of the site, in particular the amount of time that it takes for the site to become visible. Now, first and foremost, I want to explain that Wix does in fact optimize images in the sense that we convert them to the best possible format. So for example, if you visit Wix from a browser that supports the relatively new WebP format, you will see that we now use WebP for all image types. These includes both images that have been downloaded as JPEGs or images that have been uploaded as JPEGs, or images that have been uploaded in PNGs. They're actually converted into WebP. WebP is supported by Chrome. It's also now supported, I think, by Edge, and it ultimately, I assume, will be supported by all major browsers. And that results in a download bandwidth saving of could be 30 or up to 50%. So in that regard, we do definitely invest in optimizing the image. Another thing that we do is that when an image is cropped in the display, rather than downloading the huge image and then cropping it on the client side, just showing that part that actually is needed, we actually perform the cropping on the server side. Again, this can result in a significant saving in terms of bandwidth. What we don't do automatically is that we don't modify the quality of the image. So for example, let's say you have an image that you use as a profile picture for yourself on your site, and the picture that you're using, what's really important is your face, the background is not that important, then you might decide that you can afford to have the background not as sharp, and in this way make it easier for the image to be compressed. We don't do that automatically for you. We obviously can't do it automatically because we can't guess as to the quality in which you need the image. I agree that it would be great for Wix to provide tools for doing that, and I wouldn't be surprised if we do provide such tools in the foreseeable future. But until we provide all the tools that you do need, I know that there are many free options online that you can use. So the next question is, do we need to rethink about how we bundle JavaScript together when we move to HTTP 2, I assume from HTTP 1.1? And the answer is yes. Because with HTTP 1.1, you basically don't want to have more than 6 downloads from the same, let's say, domain. Or the subdomain. So maybe you can achieve greater, like increase the number of your bundles by just moving, let's say, the images to a different domain. I see a lot of websites used to do that, to have the images downloading from one domain and the JavaScript downloading from another. But even then, you're kind of limited to 6. Certainly, you don't want to go, let's say, higher than 10. With HTTP 2, you can basically go, let's say, as I mentioned, as high as 50. Now, obviously, your mileage will vary. It greatly depends on the bandwidth and latency that your users have, whether or not you're using a CDN. But definitely with HTTP 2, you do want to have to split your resources, your bundles more. You can make more aggressive use, for example, of code splitting. Next question. Can we utilize prefetch on fonts and images and videos using custom headers in the Wix environment? And would that make the page faster? Okay, so that's a really technical question specifically about Wix. But the answer to that essentially is yes. You can do that, but you need to be very careful. For example, with images, let's say you use a full width image, then because Wix automatically resizes the image on the server based on the size required, then that size required actually becomes part of that URL. So with images, you need to be very careful that the URL that you're using for prefetching will always match the URL that then gets used to actually download that image. Otherwise, you'll end up downloading the image twice, and that's obviously a bad idea. With fonts, you can definitely do that, but I would recommend that you specifically look at fonts that you might be using above the fold and only prefetch those specific fonts. And in fact, it's on our roadmap to actually do something like that automatically, but I can't yet give a time frame for something like that. There's a question about React Native and its future, but unfortunately that's not directly about performance, and it goes beyond. I do have thoughts on that topic, and you can hit me up on Twitter or via email, but unfortunately it goes beyond the scope of this talk, so I'm not going to be answering that here. Let's see if there are any other questions. There's one question about service workers, if it's being used with Wix services such as the Wix editor. Currently the answer is no, but it's in the works. Again, I can't provide time frames, but do expect to see something like that in the foreseeable future. I do want to mention that you can get a lot of the benefits that you can get from service workers in terms of performance just from using proper cache headers. In fact, whenever somebody talks to me about the value of service workers in the context of performance, my first question is, have you made sure that all your caching headers are properly set? Service workers are great if you want to, let's say, do something like offline work, or if you want to make your application seem more like a native application. But again, in terms of performance, basically you can get a lot of the same value just by using proper cache headers. This more or less concludes our first Facebook Live session. I really want to thank everybody who's taken the time to join me. Hopefully, we will have additional such sessions from additional technical people at Wix. And again, thank you all, and goodbye.